Welcome to this module from Pluralsight. My name is Andrew Mallet. I'm going to help guide you through the overview of the Linux file system. This is all working towards our LPI Level 2 exam, and this in particular is Objective 203.1, and that's named Operating the Linux File System. As we go through this, we'll be looking at the files etcfs tab and the mteb file. We'll be looking at the file /proc/mounts. We'll be looking at UUIDs, although we looked at it in a little bit more detail within the previous module when we were looking at the introduction. We'll be looking at the mount and the umount command, along with the sync command. We'll finish up by taking a look at the swap file system and seeing how we can organize swap. So many of this, or much of this, is recapping on some of the things that you would have done within your LPI Level 1 certification, but it's making sure that we can remember it and expand our knowledge to meet the objectives for 203.1, operating a Linux file system. First off, taking a look at the /etc/fs tab, or the file system table, the fields should be marked like this: the device that we want to mount, where we want to mount it to, so the mount point, the type of file system, any mount options, and that's a comma-separated list of options, whether or not we want to include it for the dump file system, and then the pass order for a file system check. When we look at the fields and their description, they're shown in the table, and we can see that this is then going to be the device or the partition, but we can also use label or UUIDs as part of a naming standard as well. Then the directory that we want to mount to, and this must be a directory within the root file system. Then the type of file system, so this could be something like ext4 or btrfs or xfs. The options, so this could be quite simply read-only or something like this, or we might build in a selection of options, and they're going to be all comma separated because this in itself is a field delimited file. Whether or not we want to enable for backing up with the dump command, so very often we just disable this with a 0, so more often than not this field will be set to 0. And then the pass controls the order in which the file system checks a file system for errors during boot time. So usually you're going to have numbers like 1 for the root file system, and then 2 for any file system we want checked after root. If we set more than one file system with the same number, I'd say it's quite common that we do set most file systems with a value of 2, then they will be checked together. But we could then separate them out so they're checked serially rather than in parallel by using values like 2, 3, 4, etc. When we look at the devices that we're mounting, then we can mount them by the UUID, and we can always use the block ID command to return the UUID of a file system. We can use something like a label, so if we've labeled up the disk, or we could just use the raw device name. But the problem we might have using these raw device names is that they can change if our devices change. So we're better off using either the label or, more reliably, the UUID. Because again, even with the label, there's nothing stopping us having two disks or partitions with the same label. For our network devices, then we could connect maybe to Samba shares, so / the name or IP address of the Samba server, and then the share that we want to connect to. Same sort of thing with NFS, but NFS then is a colon after the server name. So NFS colon and then the NFS export or share that we want to go to. We also can connect to SSH shares. So using the SSHFS client, we could use something like user@SSHFS, and then going through, let's say in this case, to the user's home directory, so /home/user. In this way, there's nothing to share out on the server. We just connect to directories that exist, but we can then mount a temporary directory perhaps on our client machine, and using the SSH file system then remotely connect to servers without us having to configure anything on the server other than enabling secure shell. So let's take a look at this. We'll work with, first of all, the SSH file system, because this is probably not as well known as other file systems.